Welcome to Finite Math, Lesson R2 on factoring. So your objectives today are to review the definition of factorization or factoring, and then we're going to go over the methods of factoring that you've learned previously. Factoring out the greatest common factor, factoring a trinomial using the AC method or the trial and error method, and then remember our special patterns. We're going to look for dots, difference of two squares. We're going to remember our big secret for trinomials. Psst. Come here. It's the big secret. Perfect square trinomials. And then we're going to look for dots and SOCS, difference of two cubes and sum of two cubes. Factorization or factoring is the decomposition of a number or polynomial into a product of factors. So you're going to have some stuff multiplied together. So when they're multiplied, when you actually do the multiplication, you get back to the original. For example, the number 15 factors into primes as 3 times 5, and the polynomial x squared minus 4 factors as x minus 2 times x plus 2, because if you multiply x minus 2 times x plus 2, you get x squared minus 4. The opposite of polynomial factorization is expansion, the multiplying together of polynomial factors to an expanded polynomial, written just as a sum of terms. Okay, we're going to factor out greatest common factor, the GCF, and you always want to check for this before you employ other methods as well. So for 3x plus 6, both methods have a factor of 3, so we factor out the 3 and we get 3, and then parentheses to indicate times x plus 2. If we multiply the 3 back through, we would end up back with 3x plus 6. Okay, for part B, we've got 10x cubed plus 2x squared, so we're able to factor out a 2 and x squared. So we'd factor out 2x squared, which would leave us with 5x plus 1. Why? Because 10x cubed, if I factor the 2 out, I'm left with 5. If I factor out 2 powers of the x, I'm left with just a plain x, just a single power of x. And then for the 2x squared, since the 2 and the x squared are factored out, we're left with just plus 1, because 1 is a factor of anything. Whenever you're factoring, if you factor out what appears to be the whole thing, you always fill in that spot with a plus 1. Okay, on the next one, let's see, we've got 8x squared plus 12x minus 16y. Well, because the third term has a y and no x's, we're not going to be able to bring out any x. All three are even, so we're going to at least be able to bring out a 2. It looks like we can bring out a 4, though, because 8 is 4 times 2, and 12 is 4 times 3, and 16 is 4 times 4. So we'll factor out the 4 and be left with 2x squared plus 3x minus 4y inside our parentheses. All right, factoring a trinomial, ax squared plus bx plus c. Always check for a greatest common factor first. So you do a quick glance of that. Let's talk about the AC method. We're going to factor x squared plus 5x plus 6. It's a trinomial, so this would be where AC comes into play. When you have an understood 1 in front of the x squared term, it's a little easier. But what you always want to do, A is 1, B is 5, and 6 is C. So you want numbers that multiply to give you AC. So let's see, 1 times 6 is 6. So the numbers we're interested in are going to multiply together to give us 6. And then they need to add together to give you B. So blank plus blank, the two numbers we're looking for have to add together to be 5. So 3 times 2 equals 6, and then 3 plus 2 equals 5. So we're going to split this up. Remember, the whole idea is to split up the 5x into the first number times x plus the second number times x. So we're going to have x squared plus 3x plus 2x plus 6. Remember, all we've done here is we've written 5x is 3x plus 2x. Otherwise, it's the same thing. We haven't actually factored yet. Now we do the factoring by grouping. We factor a common factor out of the first two terms and a common factor out of the second two terms. So let's see, we can bring an x out of the first two, and that'll leave us with x plus 3, and then a 2 out of the second two, which will leave us with x plus 3. And then whatever's in the parentheses that they have in common, that's now a common factor to the whole big thing. We've gone from 4 little terms to 2 terms, x times x plus 3, and then plus 2 times x plus 3. So the x plus 3 comes out here, and then whatever was multiplied by the x plus 3, we put in a second set of parentheses. So x plus 2. x plus 3 times x plus 2. Now, if you want to check your answers, remember you can always multiply them back out, FOIL them out. So x times x is x squared, and then we would get plus 2x plus 3x, which gives us our plus 5x, and then 3 times 2 is 6. So this works. So the factored form of x squared plus 5x plus 6 is x plus 3 times x plus 2. The expanded form of x plus 3 times x plus 2 is x squared plus 5x plus 6. All right, so let's try this again with another example, and where a is not equal to 1. Okay, so we're going to factor 2x squared minus 7x minus 15. There's not a common factor, so we can go straight into AC method. Remember, a is 2, b is negative 7, and c is negative 15. Now, we want numbers that multiply to equal AC and add to be b. So, the first number and the second number need to multiply to be 2 times negative 15. They need to multiply to be negative 30. And they need to add to be b, so they need to add to be negative 7. So numbers that multiply to negative 30 and add to negative 7. Now, one's going to need to be positive and one's going to need to be negative, so they multiply to be negative 30. So maybe, let's see, 30, an easy pair would be negative 10 and positive 3. And sure enough, negative 10 times positive 3 does equal negative 30, and negative 10 plus 3 equals negative 7. So your first step is to rewrite the negative 7x as negative 10x plus 3x. So there we've got our rewritten polynomial, and now we take the terms two at a time. We're going to factor 2x out of the first pair, and then 3 out of the second. So we're going to have 2x times x minus 5 plus 3 times x minus 5. Now, what do these two big terms have in common? Well, they have x minus 5 in common, so that's going to make one of our factors. And then our other factor is going to be made of what is multiplied by x minus 5, so 2x plus 3. Now, it doesn't matter if you write this as x minus 5 times 2x plus 3, or if you write it how I did, 2x plus 3 times x minus 5. That doesn't matter. The order of the factors themselves doesn't matter, just what's inside the parentheses matters. All right, so factoring a perfect square trinomial. Now, trinomials can be factored using the AC method. It's just a little quicker to use the factoring pattern. So this is the secret to being able to factor a little faster. So, psst, you know, that's a way of indicating a secret. So this is the secret to being able to factor faster. Now, the expanded form needs to be able to be written as x squared plus 2xy plus y squared in order to be factored as x plus y squared. Or if you have a minus there in front of the 2xy term, then you'd have a minus in your factored form. So looking at this first one, x squared plus 6x plus 9, that can be written as x squared plus 2 times x times 3. So the 2 is part of the pattern, x is the first base, and then 3 would be the second base. What we need to check is that the 9 is equal to 3 squared, and it is. So it fits the pattern when it's expanded, so we can use the pattern for the factored form. So it's going to equal x plus 3 squared. Okay, now you could get to the same place by doing the AC method. You ended up with x plus 3 times x plus 3, and then you could write it as x plus 3 squared. Let's look at part 2. It just has a minus there, so it would be x minus y squared, depending on what the bases are, but let's just make sure that the pattern fits for the expanded form. Our first base is x, and it's certainly squared. Our second base is 3, and it's certainly squared, and the middle term is equal to minus 2 times the first base of x and the second base of 3. So since the pattern fits in expanded form, the pattern will fit in the factored form. So it's x minus 3 squared. Okay, this one's a little more complicated. Look, just glance and make sure there's not a common factor. 4 and 20, well, we could bring a 4 out, but 25 messes that up. So this one's just a little, may take a little bit more to notice that this actually works. 4a squared can be written as 2a, the whole thing squared. 25 is 5 squared. Okay, so if the middle term fits, then this is a perfect square trinomial. Let's see. Since this is a minus, we'd need a minus here. And it's always 2 times first base, so 2a, times second base, so 5. So let's multiply this and see if we get negative 20a. So let's see, we get negative 2 times 2a, that's negative 4a, times 5 is negative 20a. So this does work. So the factored form here is going to be 2a minus 5, the whole thing squared. So that's just a little secret to make factoring a little easier if you have a perfect square trinomial. All right, difference of two squares, dots. We always look for dots. Notice there's no SOCS. There's no sum of two squares. Sum of two squares is 9. It has to be a difference of two squares. And it's going to be the sum of the bases times the difference of the bases. So if we have x squared minus 16, we need to think of the expanded form as x squared minus 4 squared. Yep, that works. So we use our pattern. It's x plus 4 times x minus 4. If you wrote it as x minus 4 times x plus 4, that's fine. 9a squared minus 25, well, let's see. 9a squared can be written as 3a, the whole thing squared. And then 25 is 5 squared. It's a difference, so yep, this works. So it's 3a plus 5 times 3a minus 5. X squared plus y squared is prime. That's a sum of two squares, and there's no such thing as SOCS. We know what dots is, but sum of two squares, that just doesn't make sense. All right. Difference of two cubes. Okay, so we're looking for dots, the difference of cubes. So remember, this factoring pattern you have to memorize. It's x cubed minus y cubed. It's x minus y. Notice it's first base minus second base. Okay, and then it's first base squared. So x squared plus xy plus y squared. Okay, you have to memorize that. As far as the signs go, the first one matches, and then you do the opposite, and then you end with something positive. So we're going to have a minus here, opposite is plus, and always end with something positive. All right, so just like we've been doing, we're going to make sure the expanded form matches the pattern, and then we'll apply the factored form pattern. All right, m cubed is obviously m is the base, cubed, minus. Now we need to write 8 as 2 cubed. And so it fits the expanded form. This is a difference of 2 cubes. Now we're going to write it in factored form. Now this seems kind of weird because it seems like the factored form is more complicated than the expanded form, and in our everyday use of the term expanded form, or expanded, that just doesn't make sense. It seems like the factored form is kind of expanded because it's bigger. It's just the mathematical definition of expanded is when you just have terms added or subtracted together, and factored form is when you've got prime factors multiplied together. So just kind of keep that in mind. It may seem a little counterintuitive. All right, so x minus y means the first base minus the second base. So we're going to have m minus 2. Then in our parentheses, we're going to have first base squared, so m squared, and then plus m times 2, the product of the bases, plus second base squared, so plus 2 squared. So we want to clean this up just a little bit. Instead of m times 2, we want to write it as 2m, and then 4 is 2 squared. Now, a lot of times people want to stop and look and see if they can factor this trinomial. You can stop and look, but it's always going to be prime because it's just a plain xy. If it was 2xy, we'd be able to factor further, but we can't. So if this was 4m right here, we'd be able to factor some more, but because it's 2m, we can't. So we're done. All right, let's look at 2x cubed minus 64. All right, we're going to have a more complicated first base. So you need to think of the coefficient also. 27 is 3 cubed, so 27x cubed altogether is equal to 3x, the whole thing cubed, because 3 cubed is 27 and x cubed is x cubed. 64 is 4 cubed. So this is going to be 3x minus 4 times 3x, the whole thing squared, plus 3x times 4 plus 4 squared. So we've got a little more to clean up on this one. So we'll have 3x minus 4 times 9x squared plus 12x plus 16, and we always stop there. All right, sum of 2 cubes is very much the same thing. We look for SOCS also. Because it is the sum of 2 cubes, you've got a plus inside your binomial. You're going to match the sign. And then for the signs in the trinomial part, you're going to have opposite, and then you're going to end with something positive. So m cubed plus 8, we're going to write it as m cubed plus 2 cubed, and then we're going to apply the pattern. We're going to have m plus 2 times m squared minus m times 2 plus 2 squared, and then we're going to clean up that trinomial a little bit and have m plus 2 times m squared minus 2m plus 4. Okay, 8x cubed plus 125. All right, 8 is 2 cubed and 125 is 5 cubed. So we're going to have 2x, the whole thing cubed, plus 5 cubed. So that's going to give us 2x plus 5 times 2x, the whole thing squared, minus 2x times 5 plus 5 squared. We need to clean that up a little. 2x squared is 4x squared. And then we're going to have minus 10x plus 25. So 2x plus 5 times 4x squared minus 10x plus 25. Okay, guys, do the problems to try on your own. If there's any part you don't understand, just go back and rewatch the video, come in and see me. But you need to understand the lesson well enough to do the problems to try on your own. And remember, you've got to try those in order to get full credit for doing your notes. So make sure you do that. I will either see you when you come by for extra help, or I will see you in class. Have a good day.